Hi, I'm Ben Jahnke, Agronomy Research Scientist, and I'm standing in front of some pretty interesting corn plots. The study behind me is designed to look at photosynthetic efficiency in corn. What we did here is select two different corn hybrids, and we removed leaves at specific areas in the canopy to look at and evaluate how that leaf removal affected grain yield. So our specific treatments would be removing all the leaves above the ear leaf, all the leaves below the ear leaf, and then the ear leaf itself, and one above and one below, as well as an untreated check. So if we think of the corn plant as a factory, what it's doing is capturing sunlight in the leaves, producing carbohydrates and sugars, and ultimately relocating those compounds to the ear. So it stands to reason that if we alter the leaf canopy in some way, there should be some corresponding result in impact in yield. The yield we see is a product of the source-sink relationship. So the source in this case would be the photosynthetic compounds of carbohydrates and sugars produced through photosynthesis. The sink is the ear, the place where those carbohydrates and sugars are stored. One of the goals for this study was for us to understand what effect did that leaf area removal have in contribution to overall yield. We wanted to see if we could evaluate the reduction in photosynthetic capacity and equate that back to a certain reduction in yield. What we wanted to simulate through leaf removal was some certain stressors that corn plants can see throughout the year. So things like disease, where disease lesions can congregate on a leaf and offer reduced surface area for sunlight harvest. Another one of those could be nutrient stress, where pale and chlorotic leaves are less efficient at capturing sunlight. Maybe drought, where rolled up leaves trying to preserve moisture aren't available to harvest as much sunlight. Insect feeding, where insects actually eat out areas of the leaf and reduce leaf area available for photosynthesis. Or a hailstorm, where hailstones can shred leaves and damage them to the point where they aren't fully able to contribute to yield. Something not often thought of is the total amount of solar radiation that corn plants capture throughout the year. Things like excessive cloudy days due to rainstorms, or maybe a dark haze from some of the recent wildfires and the smoke and smog that move into an area from that, can really limit sunlight capture and ultimately impact yield that we see. In some experiments that we've seen that have intentionally shaded corn to levels of 50% sunlight, the effect of that has reduced yields by up to 20%. And it's not only yield that we see the effects of reduced sunlight. Corn can become even more susceptible to lodging if sunlight is limited throughout the grain fill period. This limited photosynthetic activity at grain fill can signal to the plant that carbohydrates are in short supply and actually move them from the stalk into the ear, reducing stalk quality and integrity. We'll be evaluating this study and the effect of reduced leaf area on stalk strength and grain yield later this fall. So stay tuned for further updates on this and other studies we're doing. Thank you.